LeetCode 509, Fibonacci number. They want the nth Fibonacci number. The Fibonacci sequence is 0 plus 1 is 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, and so on. When they want Fibonacci 0, they want the 0th one, which is 0. Fibonacci 1, the first one, which is 1. 2, the second one, which is 1. 3, the third one, which is 2, and so on. The fastest way, therefore, to solve this problem will be to pre-populate the array with all 30 Fibonacci numbers and then just return the value at index n. However, we're going to do things without actually calculating them to show this caching technique with lazy initialization, memoization. We're not actually initializing objects, we're just creating numbers. So it's memoization. When this code is run, a fib identifier is created and assigned the result of evaluating the function. This arrow function returns a function. This fib identifier then points to this function that is returned. Now, as I said earlier, the fastest way to do this will be to return the number at index n. We've created an array of length 31, has a 0 property of 0, and a 1 and 2 properties having the value 1. It does not have a 3 property yet. When we call fib3, pass it 3, we check, we pass in 3. Is 3 1 or 2? No. Do we have a 3 property in memo? Not yet. So then we're going to create a 3 property, assign to memo a 3 property, and the value is going to be fib 3 minus 1 plus fib 3 minus 2. We pop 1 on the call stack, recursively call fib with 2. That results in this being evaluated as true. We return 1. Fib 1 is called, and we return 1. So now we have fib 3 is 1 plus 1, and fib 3 is 0, 1, 2, 3 is 2, is returned, and it is assigned to the memo 3 property. Exactly what we want. A subsequent call to fib 4 would result in evaluating. This is going to be false. We don't have a 4 property yet, so we're going to go to this last conditional statement here. Memo 4 is going to be equal to memo fib 3 plus fib 2. Fib 3 we've already calculated. We're going to look, we're going to add 1 to the call stack. We're going to see, is there a 3 in memo? Yes, it was. We already got the result of that. It's 2. So now we have 2 plus fib 2. We pass in 2. We pop 1 on the call stack. 2, the result of that is 1. So we're going to have 2 plus 1 is now going to be is 3, and that's going to be assigned to memo 4. And that value is then returned. 2 plus 1 is 3, assigned to memo 4 and returned, and then we're done. The problem with this code is that it can be a little bit daunting when you haven't seen this before. This is an immediately invoked function expression, or IIFE, and it uses recursion. The benefit is a lot of performance, very fast performance, at the small cost of a very small memory footprint. An array of 30 elements with each element being the value of a number. A very small memory footprint. This is a good technique to know when you're wanting to create an object pool or an object cache. This is essentially a private static variable here. The outside code can't see it. Only this function can see it. So it uses encapsulation to hide this identifier. It uses caching so that we can reuse the values that we've stored in there for subsequent calculations. And that's the part of the memoization technique. Very, very fast performance, small memory footprint.